All right, good day everyone. Welcome to our YouTube lessons with analogous. So we'll be looking at pH concept. Looking at how we calculate pH of solutions. My particular concern is those of weak solutions. So the pH concept was this first devised or was first discovered by Soren Sorensen in the 18th century. Yeah, in the 18th century, the late 18th century. Now Sorensen discovered the pH concept and traditionally gave us a pH scale as at that time it was between 0 to 14. Sorensen said 7 on the pH scale is neutral, so 0 to 7 is acidic, while 7 to 14 is basic or alkaline. So this is the pH scale, and the instrument used to measure pH today is known as a pH meter. So a pH meter is used to measure pH as of today. Now, what I'll quickly like to look at is how do you measure pH? How do you measure pH? So quickly, for measurement of pH, which is my main concern. Now, pH is actually measured by a negative logarithm of the hydrogen ion concentration in the solution to base 10. So number system is a base 10, so it's just negative logarithm of hydrogen ion concentration. So this pH is this hydrogen ion concentration. If you multiply it with the hydroxy ion concentration, you are going to get 10 raised to power minus 14. Also, I can derive POH. POH is like the inverse of pH. So POH is a negative logarithm of hydroxy ion concentration to base 10. So this is for pH, this is for this is for pH, this is for POH. Now, it should be noted that pH plus POH is equal to 14. Now, all these things I've explained, all these formulas I have given to derive the pH of a solution, they all work for strong acid. Strong acid. So we usually use this for strong solution. Example of strong acids and strong base. Acid like HCl, H2SO4, HClO4. If you have to calculate their pH, you use all these derived equation. So I'll give a simple example. I'll give a simple example as we proceed. One simple example as we proceed. Now I have my first example, which says, what is the pH of a 0.005 molar solution of H2SO4? So now this is the concentration of the H2SO4 solution, but we need to get the concentration of hydrogen ion. Now H2SO4 is a strong acid. H2SO4, HCl, HNO3, they are all strong acids. Now to get the hydrogen ion concentration first, you have to do something like this. Now, you have to do something like this. Okay, what you have to do is just now you have to take the concentration of the acid to get the hydrogen ion concentration. You take concentration of acid. Yes, for strong solution, oh, remember, times concentration of acid times the basicity of the acid. Basicity of acid simply represents the number of replaceable hydrogen ion in that acid. And the number of replaceable hydrogen ion in that acid is 2. 2 replaceable. So the concentration of hydrogen in this acid will be 0.0005 times 2, which gives me 0.001. So this is the concentration of hydrogen in this acid. So therefore, how do you get my pH? My pH is equals to minus log hydrogen ion to base 10. So in some other videos, I'm going to do a trick on how to quickly get it without using a calculator. So, but for this video, we'll just assume that there's a calculator. In the next video, in the next series, I'm going to do this thing and try and see how to do it without a calculator. So what do you do? What do you do now? So if you do this, if you impute this, you're going to get minus log 0.001 to base 10. If you use that calculator, you observe that pH is therefore equals to 3. pH is therefore equals to 3. You can be asked to calculate for this solution. You can be asked to calculate POH. POH is therefore pH plus POH is equals to 14. Remember, pH plus POH is equal to 14. Therefore, To calculate for pOH will therefore be 14 minus 3 or 14 minus pH. As simple as that. Also, you can be asked to calculate for hydroxy ion concentration. Hydroxy ion concentration. I'll do a simple question, and you see you see something now. I'll show you another example on a diverse example, and you see how it works. So example, this other question says, what is the hydroxide ion concentration from seawater given that the pH is 6.4? So given that the pH of the seawater is 6.4. Now, how do you solve a simple question like this? To solve this kind of simple question, to solve a simple question like this, we have to get the pH, we have to get the hydrogen ion concentration, knowing fully well that pH is equals to minus log hydrogen ion concentration to base 10. Therefore, to get hydrogen ion concentration from pH, it is 10 raised to power minus pH. Now, this expression should be noted, please. So, hydrogen ion concentration is 10 raised to power minus pH. 10 raised to power minus pH. So, that is hydrogen ion concentration, 10 raised to power minus pH. Also, another formula we use to solve this question is that hydrogen ion concentration times hydroxy ion concentration is equals to 10 raised to power minus 14. So if we can establish all this question is good to down. It's going to be destroyed like never before. So now let's quickly start with getting the hydrogen ion concentration. I said hydrogen ion concentration is 10 raised to power minus pH. Therefore, hydrogen ion concentration is therefore 10 raised to power minus 6.4. So what do you have as that? 10 raised to power minus 6.4. 10 raised to power 10 raised to power minus 6.4. So solving that, we should have 10 raised to power minus 6.4. Okay, minus 6.4. So that should give me 3.9 times 10 raised to power minus 7. So that should give me a 3, that's equals to 3.98 times 10 raised to power minus 7. 3.98 times 10 raised to power minus 7. That is the hydrogen ion concentration. So what about the OH ion concentration? Remember, OH ion concentration times hydrogen ion concentration is equal to 10 raised to power minus 14. Therefore, we can say hydroxy ion concentration is equal to 10 raised to power minus 14 over the hydrogen ion concentration, which is 3.98 times 10 raised to power minus 7. You can use your calculator to do that, and you will get a value. That's how I establish my hydroxy ion concentration. That's how we establish my hydroxy ion concentration. So that's that for that. I will try to take another example now that has to do with that of weak solution. For weak acid and weak base, now I approach their pH like this. I would have loved to derive the equation, but to save time, now I treat them like negative logarithm of square root of KAC to base 10. Now, for weak acid, now remember this is for weak acid or weak solutions. Weak solution. For weak acid, the hydrogen ion concentration of weak acid is equal, the hydrogen ion concentration of weak acid is equal to square root of KAC. Now, what is KAC? Ka is constant of acid dissociation. Remember, if you multiply Ka with Kb, you will get Kw. Now, what is Kw? Kw is constant of dissociation of water, and it is 10 raised to power minus 14. So please take note, for weak solution, these are how you get their pH and their hydrogen ion concentration. This is weak acid solution. Now, I'd like to give example of weak acid solution where you can use this formula. Example where you can use this formula is when you are calculating the pH of ethanoic acid or acetic acid. Yes, when you're calculating the pH of HF, hydrogen fluoride, a weak acid solution. When you're calculating the pH of H2CO3, Those are our O-level solutions that were solved that were wrong. You use this to calculate the pH of weak solution. Now, some question can come like this. They will ask you to calculate the pH of sodium ethanoate or sodium acetate. Now, this compound this compound is a sort of a weak acid. Now, if you look at this compound very well, those of us that are good, if you hydrolyze this compound, you observe that this compound contains NaOH, it was from NaOH and ethanoic acid. So, I will say compounds of weak acid and strong base are overall basic. So, compounds of weak acid and strong base are basic. So, we treat them like weak base. Now, see a compound like this. Let me give you a compound like this. Let's say ammonium chloride. Ammonium chloride. Calculate the pH of ammonium chloride, given that the K of ammonia is this. Now, the ammonium chloride was gotten, if you observe very well, it was gotten from, ammonium chloride is gotten from HCl and ammonium hydroxide. So this is the ammonium part, this is the HCl part. So this salt was therefore obtained from a weak base and a strong acid. So to calculate the pH, we treat, because it's from a weak base and strong acid, overall the solution of this guy will be acidic. So we treat it as a weak, what's it called now? Weak acid. So I'll not use the word sort of weak bases. Sort of weak bases are treated as weak acid, while sort of weak acid are treated like weak base. I'm going to solve examples. So you see them. I'm going to solve a lot of examples. So you see how they work. You see how they work. But this formula should be noted. This formula should be noted, and this formula should be noted. This formula. So know these three. That's how you calculate the pH of weak acid. Now, what about weak base? What about weak base? What about weak base? Now, for weak base, so I'm wiping it now. Now, for weak base, for weak base. Now, we don't calculate their pH directly, we calculate their pOH. pOH for weak base is negative logarithm square root of constant of base dissociation times concentration of the base to base 10, where hydroxy ion concentration is square root of KBC. Square root of KBC. Who do you solve like this? Things you solve like this are weak base. I have magnesium hydroxide. Weak base. Things we solve like this are sodium ethanoate. I call them sort of weak acid, are treated as weak base. Who do you solve like this again? NaF. Now, NaF was gotten from NaOH and HF. You see that this guy overall will be, what's it called? It will be basic to solution because it was made from a strong base and a weak acid. So when they ask you to calculate the pH of things or pOH of this kind of thing, this is the formula you should think of. And don't forget that pH plus pOH is equals to 14 any day, anytime. And this thing is most correct at 25 degrees Celsius, which we call room temperature. So I would like to try like three examples. So we'll see how it works. All right. So this other question says, what the pH of weak acid? So if a weak acid solution is 3.7, what is the pKa of this acid? What is the pKa of this acid? Very tricky. So quickly, I would like to just start with this. I've given you now, take note that pKa is equals to negative logarithm of Ka to base 10. So we can get Ka from our pH formula of weak solution. Remember, weak acid solution, how do you treat them? Minus log of what, everybody now? Square root of KaC. So now, I will just have to make Ka subject of the formula. So let me try and make Ka subject of the formula for you. Let me just give you a simple. So I can say that Ka directly is going to be equals to Ka that is going to be equals to, let me derive it first, let me not just jump. So first of all, I'll say square root of Kac is equals to 10 raised to power minus pH. Okay, square root of KAC. So this, remember for weak acid solution, this is the hydrogen ion. Because the 10 square minus, what's it called now? Of 10 square minus pH. Now, therefore, Ka is now equal to, Ka is therefore equal to, if I take it, it's going to be 10 raised to power minus pH all squared all over C. So Ka is 10 raised to power minus pH all squared. So let me circle it out so you don't get confused. All squared. Remember, there's a square here. There is a square here. So all squared. So all squared. 10 to the power p minus pH all squared all over C. That's the formula I'm going to use to get my K. So proceeding quickly, take note of these things. I'm going to wipe them off. Take note of these things, very important. Take note of these things. So wiping them off. So what do I have? So I have K. So what's my K? So wiping them off, I have K. So what's my K? So Ka is equal to, don't forget that it is 10 raised to power minus pH all squared all over C. So what's my pH? My pH is 3.7. So I'll have 10 raised to power minus 7 all squared. So 10 raised to power minus 7 all squared. So that's Ka is therefore equals to 10 raised to power minus 3.7 all squared all over, what's the concentration of the acid? So the concentration of the acid was not given. The concentration of the acid was not given. Okay, since the concentration of the acid was not given, we can go over it in this way. We can go over it in this way. We can say, we can go over it in this way. The concentration of the acid is supposed to be given, but we can go over it like this. We can say that the hydrogen ion concentration is, first of all, which is equal to square root of KAC. We can get that as hydrogen concentration is equal to 10 raised to power minus pH. First, we start that. But in the long run, we'll need the concentration of the acid. So let me check if it was given in the question. So we need the concentration of the acid. So pardon me. The concentration of the acid was given. I didn't write it. It was given because the full question says the pH of a 0.02 molar solution of an unknown weak acid is 3.7. So concentration, pardon me, my bad. Concentration of acid, concentration is 0.02 molar. Pardon. Yeah, because I almost thought, why would concentration not be given? It must be given, So back, so I can use my normal formula. So pardon me. So what my normal formula says? My normal formula says that Ka is equals to 10 raised to power minus pH all squared over concentration. So 10 to the power minus pH all squared over concentration. So don't forget this. Don't forget this formula in your hurry. Don't forget that in your hurry. So 10 raised to the power minus pH all squared over concentration. So that's this for weak solutions or weak solutions. Okay, so what is the pH? 3.7. So I'll do 10 raised to power raised to power minus 3.7. So I should have so first, so let me just repeat my, so K is equals to 10 raised to power minus 3.7 all squared over C. All squared over C. 10 to the power minus 3.7 all squared over C. So what do we have? We cannot say C is 0.02. So I represent 0.02. So 10 raised to the power minus 3.7 is, so I have a Ka equals to 1.995 K times 10 raised to the power 1, 2, 3, 4 times 10 raised to the power minus 4 times 10 to the power minus 4 all squared, remember, all squared over 0.02. All squared over 0.02. So 1.99 times 10 to the power. So I can just approximately say this one is 2. So 2 squared. So I'm going to, let me quickly solve so you see. So solving it, I should have, coming back here, coming back here. So what do I have here? So you can rewind the video to get those information back. So I can see now that Ka is equal to, that's 4. So this is 4, plus this is 2 approximately. 4 times 10 raised to power minus 8 all over 0.02. So all over 0.02. So what should we have as that? What should we have as that? That should be K. Pardon me. So I should say that's so I should say that's 4 divided 0.02. So that should be 200. So 200 200 times 10 raised to power minus 8. So 200 times 10 raised to power minus 8 should be 2 times 10 raised to power minus 6. So Ka is 2 times 10 raised to power minus 6. That is K is an equilibrium constant. So that is Ka. So now, can we quickly get pKa? So if we have to get pKa is therefore pKa, I said it earlier, pKa is therefore minus logarithm of Ka to base 10. So we say pKa now, you can now use your calculator to do this in your various houses, is minus log 2.0 times 10 raised to power minus 6 to base 10. So when you do this, you get your pKa. So let me just do it for you, for those of us that are, so I have minus log, minus log 0.000, so that should be 6. Right, the pK is therefore equals to 5.698. So 5.698 is now the pK of the solution. So I will try to solve another question and I will explain some deeper terms when it comes to weak acid and to calculate the pH of their solutions. So I'll try to solve another term, another set of questions. So you look at this one goes like this, something like this. All right. Another simple question which says calculate the H3O plus ion concentration in a solution that has a pH of 3.72. Now, I would really like to say this, that H3O plus, which is hydrozonium ion concentration for a given solution, is the same as the amount of hydrogen ion, especially in water. So in water, it is expected that the hydrogen ion to peak hydrozonium ion. So if you calculate for the hydrogen ion concentration, it's the same as calculating for the hydrozonium ion concentration, the H3O plus ion concentration. So this type of reaction mainly occur for every acidic solution. So the hydrogen ion released usually takes water molecule and produce hydrozonium ion. So the hydrozonium ion and hydrogen ion are directly proportional. So if they say you calculate the hydrozonium ion concentration, it's more like saying calculate the hydrogen ion concentration, which gets me back to hydrogen ion concentration is equals to 10 raised to power minus pH. So the solution does not indicate whether it is weak or strong. So I just need hydrogen ion concentration. So it's 10 raised to power pH. pH is 3.72. So if I do 10 raised to power 3.72, so let's say I have so I should have 10 raised to power minus 3.72, and that should give me 10 raised to the power of minus 3.72. That should give me 1.9 times 10 raised to power minus 4. So I should have hydrogen ion concentration of 1.9 times 10 raised to power minus 4 moles per dm cube, or molar. So that is how to solve this kind of question. This should not be your problem in any means. So that's how to solve this kind of question. I'll solve one last question, then I'll do justice to weak solution finally. All right. So we have a very technical question here, which says a 0.1 molar solution of sodium salt of a weak monoprotic acid has a pH of 9.3. What is the Ka of the weak acid? So I know some of us will just try to solve this question like this, attempting like just saying Now you say you just try to attempt from what I've taught in this lesson. You try to attempt this question like saying pH is therefore equals to minus log square root of KAC to base 10. You try to look for this Ka. Hello, sir. You are going to be wrong, missing it. Now, you will not be able to solve this type of question with this formula. Why? Why? If you follow this class earlier, I said salt of weak acid, especially when the weak acid is coming from a strong metal like sodium or potassium. Salt of weak acid are treated like weak base. That means we are going to solve the question like this. POH is equals to minus log square root of KBC to base 10. I'm going to use this approach to solve the question, not this. This is for weak, what's it called, acid. But because it's a sodium salt of a weak acid, it's going to be treated like a weak base. So treat it like a weak base. Now, for instance, let me give an example. So we have CH3COONA. Now, this acid is acetic acid. It's a monoprotic acid. So I'll come and tell you how to solve for diprotic acid also. The formulas to solve essentially. So for these formulas are usually, please take note. This formula is for a weak acid, or a sort of a weak base. Weak acid or a sort of a weak base, this formula. Now, a sort of a monoprotic weak or a monoacidic, pardon me, a monoacidic weak base. Now, this one is a this one is for weak acid, also weak acid. Don't forget this. Now, which type of acid? Monoprotic weak acid. This one is for a weak base, weak base, a weak base. That's a monoacidic weak base. That means a base that have just one replaceable hydrogen ion, or a salt of a monoprotic weak acid. This one uses formula. Salt of a monoprotic weak acid uses formula because such salts will behave like a weak base. Use formula. So when it is diprotic, when it is a diprotic acid or diacidic base, there's another formula to use. So I'm going to explain that before we leave this video. But let's solve this question now. We're not going to treat this question with this first formula. We're going to treat with this second. If you treat it with this first formula and find K, you will not get the answer. You get it. The answer to this question is it's a past question in one of the universities, 2.1 times 10 raised to the power minus 6. That's the answer to this solution. So I even tried solving it with this formula and I got something way out of it. So we're not going to use this to solve it. We are going to use this to solve it. So what do? We have to first go and get POH. We already have pH. So we have pH. We have to first go and get POH. Then we get KB. Remember that Ka times Kb is equal to 10 raised to the power 14. So 10 raised to the power minus 14. So we'll go and find Ka. So first step, we get POH. First step, we get POH. Because it's a sodium salt of a weak acid, we treat it as a weak base. Why do we treat it as a weak base? I said before, in solution, this salt, assuming this is the salt, now this was a monoprotic acid, this is a sodium salt of the acid. This salt was made from the monoprotic weak acid itself plus a strong base. So overall solution is going to be basic. So we use this. So remember that POH first, which is first is equal to 14 minus pH. So first of all, what's going to be our pH? I think around 6 points. So that's I should have 14. So I have a pOH to be 14 minus 9.35. So what do I have? 14 minus 9.35. 14 minus 9.35. So I should have 14 minus 9.35. Should have 4.65. 4.65 as the pOH. Now, therefore, I can get KB. Remember that pOH is equals to minus log square root of KBC. So I can make KB subject formula. We already did that earlier today. KB is going to be therefore equals to KB is going to be equals to 10 raised to power minus POH all squared over concentration of the acid, concentration of the basic solution, which is 0.1. So here we go. So we impute that for for PPOH and KB there. So let me just take this first part off. I have my POH to be 4.65. I have my POH to be 4.65. So please watch what I'm going to do now. Now I'm going to impute like this. So this is what I'm using. So I'm using this formula to get my KB. So what do I have? So for therefore my KB is now equals to, so let me just impute straight so you see it. My KB is therefore equals to 10 raised to power minus 4.65 all squared all over 0.1. That's my KB. Just impute that. That's my KB. So when I get KB, then I proceed to go and get Ka of the weak acid. So quickly, so what will be my KB? So let's go my KB. My KB is going to be my KB is going to be, so let me use my calculator. So 10 raised to the power 10 raised to the power of minus 4.65. So I have 2.2 times 10 raised to power 5. So okay, pardon me. Pardon me, I'm going to square that. I'm going to square that. Square, okay, 5.0 times 1, okay, divided by 0.1. So I have, at the end of the day, I'm going to have 5.012 times 10, okay, let me write it bolder. So therefore my KB is equals to 5.012 times 10 raised to power minus 9, I get. So that's for minus 9. So that's my KB. Yes, that's for minus 9. So now I need to get my KA. I need to get my KA. So I'm putting my KB to be this. Due to space, I'm going to take it off. So what therefore is going to be my KA? Pardon me. So I can say KA times KB is equals to 10 raised to the power minus 14. So I can get K now. K is therefore 10 to the power 14 over KB. So I have my KA to now be 10 raised to the power minus 14 over 5.012 times 10 raised to the power minus 9 over 5.012 times 10 raised to the power minus 9. So at the end of the day, you need to punch your calculator and get 2.1 thereabouts times 10 raised to the power minus 6. When you get that in calculator. So this is the Ka of the acidic of the weak monoprotic acid. So this is how you solve this kind of question. A little bit technical. So rewind and rewind and rewind, digest, then proceed to your examination or and that's it. So let me do quickly. I'll do a brief explanation before we go. Do a brief explanation before we go. All right. Now, let me quickly throw light on this. Now, this formula we'll be using for a weak solution since is usually for a weak monoprotic solution. That means a weak solution that has the tendency of a molecule producing one proton. What do I mean? So I have something like ethanoic acid. So ethanoic acid, despite it has 4 hydrogen, is monobasic or monoprotic. So it can produce just one proton per molecule maximum. So this kind of solutions, this is the formula to use to calculate their pH. I can derive it, but for time's sake, to prevent the video from being too long, I just said I should just notify you guys. So I have something like this. I have something like benzoic acid, and so on and so forth. So to calculate the pH of their weak solution of this kind of monoprotic weak acid, we use this. Now for diprotic weak acid such as H2CO3, to calculate the pH, we use this. To calculate the pH, we use this for diprotic weak solution. While for triprotic weak solution like H3PO4, remember, H3PO3 is monobasic. H3PO3 is monobasic. Yes, H3PO3 is monobasic. Okay, so it is not tribasic like it has. Though it can, despite having 3 hydrogen, it will not lose all the hydrogen in solution because of the stability of the phosphate ion. So is so this guy is pardon me, is dibasic. So It's diabasic. You have boric acid also. So this type of solution, before I deviate, this type of solution is actually this type of solution actually to calculate the kind of the pH for H3PO for not H3PO3, we use something like this. So when you come across all these kind of solutions, like a question, you quickly solve it. So what about there's this weak acid again, not they are partially. What's a weak acid? A weak acid is a substance that dissociates partially in solution. That means the dissociation of weak acid is not complete. So if you have 100 molecules of this acid, just about 10 of it will be dissociating to release hydrogen ion. So we can calculate the percentage of the percentage dissociation or the percentage ionization, the percentage ionized. So to calculate percentage ionization, I'll just give you percentage ionization of the hydrogen ion is therefore going to be for this one, monobasic or monoprotic is square root of KC over C times 100 over 1. Therefore, what about for this one? The percentage ionization for their basic solution, their product solution is the so for the protic solution, so the percentage ionization, if I do this, you'll be able to do the last one. Ionization for the diacritic solution is therefore equals to this O hydrogen ion part. I explained that earlier in the video, which is cube root of 2KAC, cube root of 2KAC. So let me just write it well. Cube root of cube root of 2KAC over C. Cube root of 2KAC over C. Then this one, it will be fourth root of 3KAC over C. That's how you get their percentage ionization times 100 over 1. So that you get the percentage ionization of these solutions. You get the percentage ionization of these solutions. So that's that for that. Don't forget that H2P, pardon me, H3PO3 is don't forget that H3PO3 is diabasic phosphonic acid. Also, there's a brother of it called boric acid. Boric acid is monobasic. So many are more we looked at in this our tutorials. So in our next video, I'll be giving a trick on how to calculate pH without calculator for those O-level students that will need it. Until the next video, it's a wrap up for this. Thank you for watching. May God bless you. If the video is necessary to you, it was helpful. If it was helpful, make sure you click the notification button and subscribe. Don't forget to subscribe. Share it with your friends. I know it is helpful. Share it with them. And until the next video, it's a bye. Have a nice day.